In this video, we will be learning about parametric equations. Imagine that you are a shop owner on the beach, selling ice cream, as well as sunblock lotion. As you made more sales of these two products, you decided to plot a graph of the sale of ice cream versus sunblock lotion. And you found that the more ice cream you sell, the more sunblock lotion you sell as well. In order to increase your sales, would it then be a fair statement to say that if I want to sell more sunblock lotion, I would then need to sell more ice cream? Let's take a few seconds to think a little bit deeper. That could it possibly be a third factor linking these two variables together? For example, temperature. On a hot day, when temperature is high, one would then expect to be able to sell more ice cream, and with such high temperature, we would also expect that people on the beach would also need more sunblock lotion. Therefore, you can see that as temperature increases, you would see higher sales of ice cream as well as higher sales of sunblock lotion. Now, with a third factor such as temperature, it will then make more meaningful sense to link the sales of ice cream to temperature and the sales of sunblock lotion to temperature. Thus, we can see that it may not always be useful to link two variables directly together, even though they may show a trend, but that these two variables may require a third factor to link them in a more meaningful way. In the example shown earlier, we concluded that the sales of ice cream is a function of temperature, and the sales of sunblock lotion is also a function of temperature. We could translate this into mathematical equations by writing X to represent the sales of ice cream, Y to represent the sales of sunblock lotion, and T to represent temperature. With this, we can describe our two variables X and Y in terms of a third variable T. Therefore, in this case, we will have two equations, X in terms of T and Y in terms of T. This set of equations are what we call parametric equations. The variable T is known as the parameter, and it is important to note that T can take on different values. For each value of T, it will give us a set of values of X and Y. These set of values are called the trajectory or curve of our parametric equations. Let's try this. Sketch the trajectory over the time interval from 0 to 10 of the particle whose parametric equations of motion are given as follows. One way to sketch the trajectory is to choose values of t and then substitute these values of t into our parametric equation to give us our set of values of x and y. We can then use this set of values of x and y to plot our graph. Now, how do we choose suitable values of t? First, we cannot have too few points or our sketch will not be fairly accurate. Second, note that t is actually a continuous variable which can take on any real value from 0 to 10. In this case, we will choose t to take values from 0 to 10 in steps of 1 time unit for convenience. With this, let's try to fill up our table. Now in this second column, x is represented by this equation. And y is represented by this equation. Let us substitute our values of t to give us our corresponding set of values of x and y. So when t is equals to 0, we have this set of values of x and y. When t is equals to 1, we have this second set of values of x and y. When t is equals to 2, we'll have this third set of values of x and y. So on and so forth until we generate our table. Once we have this table, we will plot these values of x and y on our graph. So when t equals to 0, we have x equals to 0 and y equals to 1. So when x equals to 0 and y equals to 1 refers to this point, giving us a point over here. When t equals to 1, we have x to be minus 1.52, y to be 2.38. So if you look at the plot, x at minus 1.52 and y to be approximately 2.38 will be somewhere around here, giving us our second point at t equals to 1. And we do this for t equals to 2, t equals to 3, t equals to 4, so on and so forth until we reach t is equals to 10. Once we have plotted all our points, all we need to do next is to join our points with a smooth curve in increasing order of our parameter. Therefore, giving us the trajectory of our particle governed by this set of equations. Let's take a look at this example. Find the graph of the parametric equations as shown from t equals to 0 to t equals to 2 pi. Following the steps as mentioned, first, we will need to choose values of t. Now that we have chosen our values of t, we will substitute each value of t into our parametric equation to get our set of values of x and y. Now in this table, in the second column, x represents the equation cosine t. In the third column, y represents the equation sine t. So let us now put each of these values of t into our equation to find x and y. So when t equals to 0, x is equals to 1, y is equals to 0. When t equals to pi over 6, x is equals to 0.87, y is equals to 0.5. And we do this for each value of t until we complete filling up our table. Now, let us plot the graph on our axis. We will use this set of values of x and y to plot our graph. So when t is equals to 0, x is equals to 1, y is equals to 0, which correspond to this point. When t is equals to pi over 6, x is 0.87, y is equals to 0.5, giving us this point over here. And we do this for each set of values of x and y all the way until we reach t is equals to 11 pi over 6. When t is equals to 2 pi, notice that we have x is equals to 1 and y equals to 0, which has the exact same value as when t is equals to 0. Therefore, when t equals to 2 pi, it will give us the same point as t is equals to 0. Now that we have plotted our points, what we have to do next is to join up our points with a smooth curve in order of increasing value of our parameter t. Therefore, this is the graph of our parametric equation as shown. One should be able to observe that we have obtained a unit circle centered at the origin. We can choose t to be in steps of pi over 4 since the sketch is still fairly accurate. However, if we choose t to be in steps of pi over 2, the sketch will be very inaccurate. Note that for our choice of t in steps of pi over 6 provides the most accurate sketch.